Welcome to Decarb Connect podcast. And today I'm joined by Simon Ighofose, who's the co-founder and CEO of PyroGenesys. And we are, I guess for this one, kind of looking at a very early stage business trying to tackle elements of decarbonization, but also really with this fascinating lens on how off-grid communities can get more out of, I guess, the reutilization of waste and other circular economy initiatives. So Simon, can I ask you just to give a little bit of an intro to how have you arrived at this point in time where you have founded this business and you have this focus? Can you tell us a little bit about that?
Thanks very much for hosting me today, Alex. Pleasure to speak with you and your listeners. Yeah, it's really come about as a result of, first of all, going on one of those life adventures, seeking to do something different. I'd left local government and was seeking to set up a business in Nigeria that was going to be involved in manufacturing cassava starch. I had a manufacturing partner who was going to put up capital and supply the equipment and buy all the products that we were going to make once I could set up a factory in Nigeria. And so I went out to Nigeria, spent 6 months out there. And, whilst I was looking around, I realized that a lot of other similar businesses that were trying to produce cassava starch and flour weren't doing too well. And the reason being was that they typically use diesel to run their generators for their electricity and even potentially for giving them heat as well. So they were burning fossil fuels and also firewood in order to give them their heat and their electricity. And at the same time, they were producing a lot of waste. And it just so happened that there was an open source academic article that was authored by Professor Tony Bridgewater and Dr. James Titiloy from Aston University. And they were showing how they were converting cassava peel into diesel, kerosene for jet fuel, and value-added chemicals. And I thought, wow, well, Nigeria runs on diesel generators. If I could produce diesel from, agricultural or agri-food processor waste, I'd have a business. And so, that's where the kind of like the moment of epiphany, if you like, occurred. And I was like, right, well, why don't I, do a massive pivot, head back to the UK and sign up to do a chemical engineering degree at Aston University and learn how this technology works. And spent 6 years in my adult life retraining to become a chemical engineer. And for my master's research project, I did just that. I was using catalytic pyrolysis, converting biomass into jet fuel components. After I finished and submitted that, I registered PyroGenesys with a view to then inventing my own technology that was going to enable that. And here we are today.
Incredible story. So just as a kind of, even going back a bit further, were you a scientist? Were you into science earlier in life, or was this a total kind of shift in academic perspective and everything else? What was the background?
Well, immediately previously, as I said, I'd been working in local government. So I was managing, funded programs. So I had a lot of project management background. And whilst at Leicester City Council, I was the first non-executive director of the City Council. And so I was sat on, board of directors that was running the city. And one of the things that, really fascinated me the most was how a city manages its waste. So I saw the different challenges. And, I thought this is a really underutilized resource. There must be something better we can do with it. So that gave me the context of like, we need to look at ways of, utilizing waste. But before that, yes, I'd studied, chemistry, biology, physics, maths, and, always found them really fascinating. And I have that inquisitive mind. So I was always searching, I had an inventive and, creative, way about me that, I remember on my LinkedIn profile when I first started at university, I was like, oh, I'm going to invent my own technology. I'm going to invent my own system for doing all of this, for solving this problem. And lo and behold, several years later, it actually happened. But that required a lot of other skills. That was about piecing together the funding, raising the financing, and the match funding, and everything like that.
So then let's talk about the company. So you've explained a little bit about the kind of the goals that were driving you when you were kind of doing this big retraining and then launching. But tell us, like right now, what is the space? How do you describe the space that PyroGenesys occupies? And where are you at? What kind of stage of development are you at the moment? And then we'll talk a little more about those drivers of off-grid communities and decarbonization and more generally. But tell us about the kind of the stage of the business and as I say, what place does it occupy in the market?
Okay, so the stage of the business, Alex, is that we have, utilizing the resources that we've been able to access, we've built a containerized machine. So it's like a pilot plant. It's in the factory at the moment. We've done initial tests, factory tests to identify, all the snagging issues. We've upgraded certain components and, so it improved the way it operates so that it can operate continuously and robustly, running on a wide variety of different feedstocks. So we're about to finalize all the different changes, and then we'll do the next round of factory trials, and which we hope will be successful. And then, based on that, it's then good to go to site. And that's like a live test site, which we're hoping would be at the Thornton Science Park, which is in the northwest, right next to the Stanlow Oil Refinery. And that's where we can then start running the pilot unit on a 24/7 basis. We would want to be testing a number of different waste feedstocks. So I'm at the moment, in Nigeria, looking for, potential customers, prospective customers who have, they generate a lot of waste because they tend to be like agri-food processors or large agricultural operations, and they need a lot of heat and electricity. So the idea is to test their waste in our machine. We can demonstrate the business case is viable. And then on the back of that, we can hopefully get supply contracts to, send our machines, which we would operate business to business. We would own, operate, and maintain the equipment, and we would be selling energy as a service. So we would sign power purchase agreements with them. And we also produce, biofuels, both solid and liquid, which we would be looking to have offtake partners to purchase those that we already have in place as well. So in a sense, that's our kind of like first go-to-market stage, is working with manufacturers. And then from there, we would look to expand out to the communities that supply them. And it's all about creating energy access in a market where, energy is very sporadic.
Okay, and then that leads me neatly into the next question, really, which is you sort of talked a little bit about this idea of, or rather not the idea of the focus on Nigeria, off-grid communities, but what are the market opportunities that you see both? I know when we did the prep chat for this, you were obviously primarily focused on off-grid communities, but also you were talking about potential applications in developed markets as well.
Right, so for UK, what we realized is we started getting inquiries from businesses that were looking to reduce their carbon footprint. And, they typically might produce waste, so they have a waste management or waste disposal, problem, or it's costing them quite a lot of money. And if this is waste that we can treat through our system, then we can effectively, especially they would ideally be using low carbon heat. We can't generate electricity necessarily competitively to, what you can buy it for in the UK. But heat, we can compete with heat on a low carbon basis if you want to reduce your carbon footprint. So we realized that we could provide like an on-site waste disposal, at our pilot scale. And also, from the biochar that we produce, we have various routes that we can sell that biochar into. That then means that it's a sequestered carbon. And as a result, effectively, that as a sequestered carbon, it's in solid form, it's inert, it's very stable, it doesn't decompose and return to the atmosphere for at least 100 years. So in effect, we're taking carbon out of the atmosphere. So it's a carbon removal solution that we can provide to businesses in the UK, Europe, America, using the existing equipment that we've got.
But then, so having asked about that kind of wider opportunities, just coming back to your original driver, which is quite a personal one for you, right? Which is enabling off-grid communities to utilize waste and so forth. Again, tell us a bit more about that. So what types of communities, what types of manufacturing operations would this apply to? Can you sort of paint a bit of a picture for that original market that you had identified?
Yeah, so when we were looking at the type of projects that we wanted to get involved with, and we got funding from Innovate UK. We had 4 projects that were funded through Innovate UK, and they were all focusing on sub-Saharan Africa and providing energy access. So it's typically the case that you have agricultural communities that they're primary producers, and they sell what they harvest to other people who then process that. So if they had access to heat and electricity, they could add value to their produce. And so this is where we've done a lot of work to explore the business cases where they will be viable. And this is the really exciting market, because it means that we are addressing the needs of what they call the bottom of the pyramid. So these are typically the families that might live on less than $1 a day, and as such, that means that they can't really afford to spend much on things like electricity. That's a complete luxury. So the fact that we produce these other commodities that we can sell means that the price of the electricity, we can make sure that it's affordable to them and give them access to it. And they just happen to produce the feedstock that we need to put into our machine. So it's a model that balances itself out, because we have more than one income stream. That's how we can be competitive in a market that's not very appetizing to many other people who are trying to provide energy access in the form of like solar panels or that, because it costs a lot of money to invest in the mini grids to distribute the power to those end users. And that's why in one of our projects, well, actually 2 of our projects, we work with battery technology providers, and use batteries to distribute electricity as a cheaper way than investing in the infrastructure of a mini grid.
Really interesting. And so those kind of those primary audiences, the people that are producing agricultural product, producing cassava, and then it goes off to be processed into other products. What sorts of things is cassava used for?
Yeah, so most people might know cassava as tapioca, and it's used nowadays. The gluten-free industry has grown up, so and also the vegan industry has grown up. So the cassava flour or starch is ideally suited to those products, and so it's gaining traction in those markets. Cassava is also, the Chinese have been investing heavily, purchasing chipped dried cassava and shipping it back to China to turn it into ethanol, and then sell it back in blended fuel products. So and now of course ethanol is very big on hand sanitizers. So cassava is one of the staples that you can use very cheaply and easily to make ethanol, bioethanol, and then all these other additional products as well. You can use it to make sweeteners, sorbitol. Nigeria has a sorbitol, at least one that I know of, sorbitol plant now, and this is another way of avoiding the sugarcane industry, and I think it uses far less inputs as well. So there's a lot of different applications of cassava that feeds into industrial supply chains.
But I mean, ultimately, from a purely commercial perspective, then your users, your prospective client bases are in a market that is growing, and you have a product that can add more value to what they're doing anyway, as well as those other kind of additional benefits. So it's kind of a nice kind of growth potential story, right?
Oh yeah. And I mean, the thing with we've chosen Nigeria for many reasons, but it just so happens that it's the world's largest producer of cassava as well. And we've tested the different wastes that you can get from cassava and found them to be very suitable feedstocks. So once the country gets going on investing in, providing an industry that uses and converts cassava, it's really going to create a lot of wealth and economic opportunities to local people, because although Nigeria is the world's largest producer, it hardly exports anything, and that's because it's a staple, for most, a lot of people in the country. So there's actually most of the cassava that's grown at the moment is for human consumption, and everybody knows how to plant and grow cassava pretty much in Nigeria, even small children. So it's a great crop to mobilize, because it has all these industrial applications as well that could create hundreds, if not thousands, tens of thousands of jobs. For one of our installations, we've calculated one installation alone could support 400 jobs in that, in the cassava supply chain, in the value chain. So, that just shows you the kind of potential that we're talking about from just, one feedstock.
Mm. And then, so the core technology then, pyrolysis, I know you've explained it to me, and I found it really interesting. Do you find it something like, does it have a good level of understanding in the investor community? Is it something you're typically having to educate people on, or?
Yeah, pyrolysis is not necessarily that well known as a technology, or understood, I should say. Everybody knows it intuitively because they meet it every day, without realizing. And the problem is that there have been various ventures in the past that, where they haven't managed to get it to work commercially. So investors can sometimes have had their fingers burnt in the past and are a bit shy, when you mention pyrolysis. But nowadays, I see a lot more emerging, companies that are emerging who are using pyrolysis technology. And that's because it's a very powerful technology. It's good at what it does if it's done properly. And it's effectively a thermal separation. So when you add air and you've got heat, you get a flame, you start a fire. But if you don't have any air, you don't start a fire, you don't burn things. So effectively what you've done is separate them from a solid state into a gas state. They become like a vapor. And then that means that those vapors are, hydrocarbons. And just like a petrochemical industry, specializes in converting hydrocarbons into all sorts of end products. Well, pyrolysis has sped up what geological processes have taken millions of years to do, in a matter of minutes. So it gives you access to, materials that you can then reconfigure depending on what the end use application is going to be. So it's the workhorse to give you raw materials that you can then feed into other processes to upgrade to, value-added products.
So coming back to the business, I think one of the things I really liked about the story and the kind of, well, not just the technology, of course, but the story around your business is that you're bringing this lens of not just what it could do in the UK or the US or in, a kind of pretty developed market, but that you do have this lens on Nigeria and other opportunities. So like, what's your sense of, like, how can you build on that? Where next? Where next is obviously the pilot plant, and we'll come back to that in a minute. But what's your sense of a kind of a wider opportunity beyond Nigeria, do you think?
Because one of the products is biochar, and biochar, as I said, when it's sequestered it into, say, agricultural soil or horticultural applications, effectively you've removed carbon from the environment. So this means that a manufacturer who produces a waste that we can convert into a biochar can effectively decouple manufacturing from carbon emissions, because at the moment, manufacturing goes hand in hand with emission growth. Yeah. So if you're going to manufacture something, you're going to create emissions. Well, how about if we could actually remove those emissions from the manufacturing process and make, potentially you could end up with a negative carbon, manufacturing process. So that's why we're looking to explore with manufacturers who produce a combustible waste. So anything that will burn is something that we can treat using pyrolysis. Whether or not so if it was an organic material, that's why we would call it biochar. If it was not, say it was plastics, then it would just be a char, pyrolysis char. But at the end of the day, if that char is and it's typically going to be a high carbon content material, if we can find a way of locking that into something and locking it away from the environment for over 100 years, then we have a carbon removal system. And then that's why you can start saying manufacturing can continue to grow without the growth of emissions. I think that's the most powerful application of this technology at this time.
And so right now then, so you mentioned that literally the next step for the business is this pilot plant in the northwest of the UK. So what is it that's most important for you to prove next, do you think, in this process?
And most investors I speak to say to me is, "Oh, have you got an operating system?" And I'm saying it's on its way. So they all want to see that it's clocked up at least 1,000 hours fault-free continuous operation, Alex. And so that means that it can then fit into a regular maintenance regime. So that will provide technology validation. And then from the data that we produce, we'll be able to do like the mass and energy balance. So we'll be able to show you, right, for every ton of this material that we put in, this is how much heat and electricity and biofuels that we're going to get out. And then that underpins the business case to say, is this going to be commercially viable, in this application, or at this scale? So that's the information that, the commercial and the technology validation that everybody wants to see. They want to see that it's robust. How efficient is it? Making those conversions, and we will have the data. So I won't just be saying, "Oh, it can do this." I'll be saying it does this. Yeah, and here's the data to back it up. But unlike, say, like a petrol or diesel car, where if you put a petrol in that car, you know how many miles to the gallon, and likewise diesel. Every different feedstock is different. Yeah. So from one factory to the next, they could both be, say, timber yards, for instance, but the timber shavings from one yard is not going to necessarily give you the same performance as the timber shavings from the next yard because of the variability of where they source their material from. So variability is the other thing. That's why we have to test every different feedstock from every source that we're going to hopefully operate with.
Okay, so the variability piece is just so that you're then able to sort of show, that like a comparison of what different feedstocks would be able to generate.
Yeah, so we can tell you what we're going to give you based on what we're receiving.
Tell us a bit about how you have funded so far, and what is the plan for sort of fundraising and next steps?
So all of the team, pretty much, that are involved in PyroGenesys, all the early stage, people that are involved have typically invested. I invested heavily myself. I sold my house so that I could invest what the company needed at the time, and that enabled us to leverage grants because we used those investments as match funding. We also managed to pick up some contracts along the way to do some testing and to do feasibility studies as well. And these are part of our core competencies. So, Dr. Joseph Ecke, who's my co-founder, he's published several peer-reviewed journal articles on, the pyrolysis of, different types of wastes, the techno-economic analysis and appraisal of, using pyrolysis as a technology in certain settings. So if you were to Google him, you'd find some really interesting articles that you could read up. And these are our core competencies in that we can, if you've got a waste stream and you want to know what can you do with it and can you add value to it, well, that's something that we can help you with. We would do that on a contractual work basis. However, those kind of contracts aren't going to give us the amount of money that we need to do the extended trials, which is where we're at now. So we're in our first kind of investment raise. We're talking to a number of different impact investors, are the ones who are most keen to speak with us, because they typically want to create positive benefits to society, especially in less developed countries, and they see how we can help them achieve that. So out of that, we're hoping to raise the capital to be able to have done extensive trials that demonstrate that the technology is robust, it's efficient, and it's profitable. And then the next stage would be to sign contracts with the kind of companies who then say, yes, thanks for testing our waste. We now want you to bring your machines and install them at our locations. So that's where we're at the moment. So we will be publicizing a bit more of that on the internet very shortly.
Okay. And just obviously people listen to podcasts at different points in time. So if you're just finding us, this conversation is June 2021. So Simon, in that context, what's your, I know no one can ever, you can't plan exactly, but what's your sense of timeframes for tests on the pilot plant and next funding round?
We're waiting for a couple to hear whether we've been successful with a couple more grants. This month, hopefully, we should find out whether we've got one of them that then gives us the green light to move everything from the factory to our test site. So if that's successful, by next month, you would see us, operating our equipment at Thornton Science Park, on a 24/7 basis. Yeah. Part of the meetings that I'm having as well in Nigeria is to, regardless of whatever happens with the grant funding, I'm looking for, prospective customers who are willing to fund similar trials that would facilitate that work as well. So one way or another, we're hoping that by July/August, we're going to be, on site operating 24/7 with our machine.
For anyone interested in a bit more information, I'm going to pin Simon down after this recording to share some links that we'll put in the show notes. So you can find show notes definitely on our website in the Insights page. And I think you can usually see them on iTunes. We can provide, just some links to some of the articles and introductions to the technology there as well. Well, Simon, thank you so much for talking us through that. I mean, I'm just always amazed and in awe of people who are doing what you're doing, like this real early stage but massive potential technology. I mean, I'm sure it must be a combination of emotions when you're building a business around this.
Well, it needs people like you as well, Alex, because, there's a lot of people who, don't realize that there's such a powerful technology that's about to transform, very big parts of the world. And it will do just that, because, the implications of what we're talking about, the liquid biofuels, the target biofuel that we're looking at producing is kerosene. And in one of our projects, in the lab, we've proven that we can take, agricultural waste and turn it into kerosene without the oil industry or the petrochemical industry. Yeah. So can you imagine if you've got, tens of thousands of villages all over, less developed countries who are now producing their own kerosene? Yeah. That's going to plug them into a global economy because you can export kerosene. It will transform the economic opportunities for, these type of communities. And that's what really motivates me. At the end of the day, it's kind of like, it's a calling. It's like I suddenly, when I had that epiphany moment, I didn't realize it, but it's kind of like I discovered my life's purpose. And so most of the people that you'll find working at PyroGenesys are equally as excited as I am, because they can see the impact that we're going to have once we get going. And we just can't wait to get started. But we do need a little bit more support because we're at that kind of like hanging over the valley of the shadow. What was it? The valley of death. Where we've got the machine, it's in the factory, we've just got to show that it does what we designed it to do. So yeah, that's why, opportunities like this to speak to your listeners, Alex, is great. So thank you very much for what you do as well.
You're welcome. And we will hopefully get an update from you. Maybe we can share that in our newsletter later in the year when you're a bit further along. Yeah. And again, anyone who has any questions about the business or anything else, either get in touch with us or we'll make sure we provide a link to Simon's LinkedIn account or something like that on our webpage so that you can get in touch. Thanks again, Simon.
Thank you, Alex.